Welcome student, standard 9th, subject mathematics 2nd, unit number 5, quadrilaterals. We will study practice set 5.1, example number 4, 5 and 6. In last video we see properties of parallelogram and first 3 examples in practice set 5.1. Now today we study the example number 4, 5 and 6. What is the example number 4? See, ratio of measures of two adjacent angles of parallelogram is 1:2. Means parallelogram is given ABCD is a parallelogram. The adjacent angle, any two adjacent angles, for example A and B, these are two adjacent angles. Their ratio is 1:2. Means if first angle A is x, then second its adjacent is 2x. Then find the all measures of angles. How can we find? Use the property of adjacent angles of a parallelogram. What is the property? Adjacent angles of parallelogram are supplementary of each other. Now here let quadrilateral ABCD is a parallelogram. This is given, and also given that adjacent ratio is 1:2. Therefore we have to assume that angle AX, then angle B, its adjacent is 2x. Now write down the property. We know that adjacent angles of parallelogram are supplementary of each other. Use this property. Angle A plus angle B gives 180. Means x plus 2x is equal to 180. 3x gives 180. X is equal to 180 divided by 3. By dividing 3 6 are 18, 3 zeros are 0. Means x is equal to 60. Now x means measure angle A. Therefore angle A is equal to x is equal to 60, and angle B means 2x is equal to 2 into 60 gives 120 degree. Now remember that opposite angles are congruent. Also opposite angles of parallelogram are congruent. Use this property. Therefore angle A means angle C is equal to 60 degree, and angle B is equal to angle D is equal to 180 degree. Hence we find all the angles of quadrilateral ABCD. Example number 5. Read carefully. The diagonals of parallelogram intersect each other at point O. By using this, we draw a rough figure. ABCD is a parallelogram. Its diagonals means diagonal AB and BD intersect at point O. Also note the given measures. OA has 5, BO has length 12, and AB, see here, AB has length 13. Then our aim is to prove quadrilateral ABCD, show that it is a rhombus. Now when given parallelogram is a rhombus, by using their diagonal property, see, the diagonal property of parallelogram is diagonals of parallelogram bisect each other. means if these two diagonals intersect at point O, then OA is equal to OC and BOA is equal to OD. And what is the property of diagonal property of rhombus? Diagonals of rhombus are bisect each other at right angle. Means bisect each other. This property is same to parallelogram and rhombus, only perpendicular. If we prove these two diagonals are intersect at each other at right angle, means here we prove it is at point O right angle, then given parallelogram is a rhombus. Means if here we prove angle AOB is a right angle, means angle BD diagonal AC perpendicular each other, then we say that given quadrilateral is a parallelogram is a rhombus. So first we write down, let quadrilateral ABCD is a parallelogram. This is our given parallelogram. Also given that, see in triangle AOB, AO has 5 unit, OB has 12 unit and AB has 13 unit. Now we square all these sides, means we square AB square is equal to, we get 13 square is equal to 169, and squaring and adding OA and OB, we get OA square plus OB square is equal to 5 square plus 12 square, means 25 plus 144 gives 169. Now from equation 1 and 2 we conclude that from 1 and 2 we conclude or we get AB square is equal to, because its right hand sides are equal, therefore we conclude that AB square is equal to OA square plus OB square. Therefore, by using where this property is proved in a triangle, if one side square is equal to sum of squares or remaining two sides, then it given triangle is must be a right angle. Therefore, by converse of Pythagoras theorem, we say that triangle AOB is a right angle triangle. Right angle triangle at angle O, means angle AOB is equal to 90 degree. Therefore diagonal AC perpendicular diagonal BD. Then write down, when diagonals of parallelogram perpendicular to each other, therefore quadrilateral ABCD is a rhombus. Therefore hence we write down, hence quadrilateral ABCD is a rhombus. We can prove this. Example number 6. In example number 6, what is given? PQRS and ABCR, these two quadrilaterals are parallelogram, and angle P means QPS, this angle is 110 degree. Our aim is to find the all angles of measures of angles ABCR, means angle A, B, C and R, both 4 angles we want to find. How can we find? Use the property in a parallelogram, opposite angles are congruent and adjacent angles are supplementary of each other. Now if angle P is 110 degree, then angle R is also 110 degree, because angle P and R are opposite angles of a parallelogram. Therefore write down, let quadrilateral PQRS is a parallelogram. Therefore angle P means angle R has measure 110 degree. Write down, These are opposite angles. Now see in quadrilateral ABCR. Now in quadrilateral means parallelogram. In parallelogram quadrilateral ABCR. If angle R is 110 degree, then angle B is also 110 degree. Angle R is equal to angle B is equal to 110 degree because these are opposite angles, and opposite angles of parallelogram are congruent. Now see here, these two angles are supplementary of each other because they are adjacent angle. Angle A and an angle R are adjacent angle. Adjacent angles. Therefore, their sum is 180 degree. But angle R is given 110 degree. Angle A plus 110 degree is equal to 110, 180. Therefore, angle A is equal to 180 minus 110. Angle A gives measure 70 degree. If angle A is 70 degree, then angle C is also 70 degree. Angle A, angle C is equal to 70 degree. Write down, these are also opposite angles. Therefore, in quadrilateral ABCR, angle A, angle C is equal to 70 degree, and angle R and angle B has measure 110 degree. The last example 7. You solve by using the properties of parallelogram. Here practice set 5.1 is completed.